Welcome to our presentation. We are the Product Capstone Project team with team ID C242-PS362. In this video, our team will introduce our application named Diabtic as an early prediction application for diabetes risk. Next. Here is the composition of our team, which consists of 7 members. From the machine learning path, we have Luthfiyyah Wahyu, Irendra Lintang, and Muhammad Iskandar. From the cloud computing path, we have Septian Ade and Daniel Cahya. And from the mobile development path, we have Muhammad Rafi and Fahmi Hanafi. Next, we will explain the background behind the creation of our application.
Okay, good day everyone. Thank you, Ade, for the time and the change. To set the stage, we begin by highlighting the pressing global impact of diabetes. This slide shows some key statistics and articles underlining the widespread prevalence of diabetes and its significant health burden. Next. For the background, diabetes affects millions globally, making detection and monitoring management is essential to reduce health risk. Diabtics addresses this need by using cutting-edge AI and machine learning to deliver the first one, personalized risk assessment tailored to individual users. Second one is health tips to encourage better lifestyle choices. And the last but not least, news updates related to diabetes to keep users informed. Next. Why diabetics? What is our reasons? Our project is particularly relevant because of Indonesia's ranking among the top 10 countries for diabetes cases. This inspired us to create a tool to empower vulnerable communities with accessible healthcare solutions. We aim to tackle the high diabetes prevalence both in Indonesia and worldwide by providing a user-friendly and affordable platform for prevention and monitoring. Our ultimate purpose is to shift the healthcare focus from reacting to health issues to proactively preventing them. Next.
Okay, thank you, Arin. Let's directly jump to the slide. We're looking at the current state of the app, which is designed to help users manage and monitor their blood sugar level effectively. The app help users manage diabetes by logging glucose readings, tracking trends, and recording key health metrics. By integrating machine learning to predict diabetes risk, making it a more comprehensive and valuable tool for users. Next. These are tools we use to develop and deploy the app. We use Android Studio for the mobile development, Figma for the UI UX design, and VS Code as the primary code editor, Postman for API testing, Docker for deployment environment. In machine learning models, we are using TensorFlow and Python with Flash for deployment. We use Node.js and Express for the backend APIs, Google Colab for collaborative coding, and Google Cloud for scalable cloud solutions. Next. Diabtic help users manage diabetes by tracking daily glucose readings, logging health metrics like meals and medications, and monitoring trend over time. Integrating machine learning to predict diabetes risk will add significant value, which make the app more comprehensive as tool for diabetes management. Next slide will be delivered by Rafi.
Okay, here mobile architecture, we are using MTTM pattern, which involve two models, one from the API and one from the room entity. The process handling the model is managed by the repository. Although that not all feature we are made are used this model book. Okay, next.
The data flow in our application begins with user uploading their data through the apps. The main API we built on App Engine receives and processes this data. For prediction, the main API on App Engine sends a request to the Flex API hosted on CloudTron. The Flex API, upon receiving the request, loads the machine learning model from cloud storage, which was preloaded into memory during container startup, generates a prediction, and returns the result to the main API on App Engine. Then, both the prediction result and the user data are stored in the file store.
The Diabtic backend API uses 5 HTTP methods to manage data on the server, including get, to read data from the server, post to send data to the server, put is used to update existing resource on the server, patch is used to update partial data on the server, and last is delete is used to remove data from the server. The proper use of these HTTP methods ensure that the API operates in a structured and efficient way to manage data and user requests.
I will explain the reasoning behind our approach. First, diabetes classification automates health data analysis to predict diabetes risk, helping users quickly understand their condition. Second, clean architectures ensure scalability and easy maintenance by separating logic from technical implementation. Finally, Firestore simplifies development with seamless integration, authentication, and efficient database management. The model we've built is a sequential neural network with 4 layers. It has 4,289 trainable parameters, offering a simple yet effective structure. These result graphs show the model's performance over 50 epochs. Training accuracy exceeds 90%, while validation stabilizes at around 85%. Both training and validation loss decreased, showing improved predictions. And the classification report for our model overall accuracy reached to 91%.
Okay, then let's look at the feature through the result. There has authentication page so the user can securely log in with their credential. Secondly, there has dashboard to display key feature. Thirdly, medical history so the user can track their past prediction. Fourthly, related news to provide curated article about diabetes management and prevention. And lastly, prediction for user input. They need their data age, gender, weight, and lifestyle habits to receive a personalized risk prediction. Next. And we also maintain detailed documentation accessible via the AR code or the GitHub repository link shown.
Okay, this is a local deployment. For the next month, we planning. First month, we promote the product and evaluate of the user feedback. And the second month, we being implemented the change and update to both the application model and the server. And the third month, we continue develop and research while the preparing the first testing phase. And the fourth month, we conduct the first testing phase and document positive outcome and issue. And the 5 month, we conduct the second testing phase and record the minoritas issue. And lastly, 6 months, we fully launch the project and mentoring it performance. But before that, we made the deployment plan when firstly we planning the development, and after that we try to create the UI UX design, pricing layout, and then create the dummy data. And after API is already, we are implementation it, and then lastly we testing it.
Our total budget for this project is $130, which is allocated toward both the development tools and cloud computing resources. For our resources, we rely on App Engine, Cloud Run, Cloud Storage, and Firestore. The cloud computing expenses for these services are minimal, with an estimated 66 cents a month for the resources we use. And now, let us show you our demo app in action.
That concludes the presentation of our application, Diabtic. This application was designed as a solution to help the community easily predict the risk of diabetes early, with the hope of raising awareness and improving quality of life. This project not only demonstrates our team's collaboration, but also reflects our commitment as a Bangkit Academy participant to contribute through technology. We extend our gratitude to our mentors, instructors, and everyone who has guided us throughout this capstone project journey. We also hope that Diabtic can provide significant benefits in the future. Thank you, guys.